What if humanity's greatest construction project wasn't on Earth, but on Mars? A world frozen, silent, and lifeless, yet hiding the raw potential to become our next home. For centuries, Mars has been the symbol of mystery and possibility. Now, scientists believe that with a $200 billion megastructure, and eventually trillions more, we could begin reshaping this distant planet into a world fit for human civilization. This is the story of humanity's boldest dream yet: terraforming Mars. Mars is the closest planet that could support human life, but every part of it fights against us. The air is too thin to breathe, nearly 100 times thinner than Earth's atmosphere. Temperatures plunge far below freezing every night. Dust storms stretch thousands of kilometers across the planet, and the surface is constantly bombarded by dangerous solar radiation. For humans to survive here permanently, we must change the planet itself, warm it, protect it, and rebuild the atmosphere it lost billions of years ago. And the plan to do that begins with an enormous magnetic shield placed in space. This enormous shield wouldn't orbit like a normal spacecraft. Instead, it would float in a perfect zone of balance between Mars and the Sun, a gravitational sweet spot known as the L1 Lagrange point. In this position, the Sun's pull and Mars' gravity cancel each other out, allowing the shield to remain suspended almost effortlessly in space. But this structure isn't a solid metal plate or a giant physical barrier. It is an immense electromagnetic system stretching kilometers across, designed to generate a powerful artificial magnetic field. Its mission is simple, yet monumental: to restore the protection Mars lost billions of years ago. When the planet's core cooled, its magnetic field vanished, and its atmosphere was stripped away by the Sun's deadly radiation. With this magnetic shield active, the transformation begins. Harmful solar radiation weakens. The atmosphere stops leaking into space. Air pressure slowly starts to rise. Temperatures begin to climb. Ice becomes stable and eventually melts. And for the first time, future human settlements become possible. But even this is only the first step. Waiting for natural changes to occur over centuries is far too slow. To speed up the transformation, engineers propose giant orbital mirrors, massive reflective structures stretching across kilometers, placed high above Mars. Their purpose? Focus concentrated sunlight onto the frozen poles. As these poles warm, the ancient ice and trapped CO2 begin to escape into the atmosphere. The air thickens, the greenhouse effect strengthens, and a slow but unstoppable warming cycle begins. A chain reaction that could turn a frozen, hostile world into a planet capable of supporting life. On the ground, atmosphere factories release engineered gases for rapid climate modification. Towering like industrial cathedrals, they hum day and night, churning pressurized vats and sending warm, hazy plumes into the thin Martian sky. Powered by advanced solar farms that ripple across the plains like glass oceans and next-gen nuclear reactors drilled deep into the regolith, these factories work tirelessly, reshaping the planet one molecule at a time. As Mars warms, human presence expands. The first settlements rise under massive protective domes, sparkling like clusters of glass bubbles scattered across the red desert. Inside, breathable air, green parks, flowing water, artificial rivers, and cities designed for a new era. Schools, research labs, and community centers thrive beneath translucent shells, each dome forming a self-contained ecosystem where life can flourish despite the harsh environment outside. Transportation stretches across valleys and craters. Magnetic rail lines hum across the barren plains. Autonomous rovers haul supplies and equipment, and underground radiation-safe tunnels connect habitats during violent dust storms. Every dome, farm, pipeline, and reactor is a deliberate step toward a future where humans may walk freely outside, breathing air built over centuries. But transforming a planet is the greatest challenge in human history. A magnetic shield in deep space requires materials humanity has yet to perfect. Atmosphere factories cost trillions, and Martian dust can cripple solar arrays for weeks. The soil, rich in perchlorates, challenges every attempt at agriculture. Unpredictable atmospheric reactions may slow progress, and extreme weather can force entire settlements to pause operations. Terraforming Mars isn't a project for one generation. It is a mission for many, a relay that could last hundreds, even thousands of years. A legacy passed down through time, where future engineers, scientists, and citizens inherit the work of those who came before them. Yet, if we succeed, the reward is beyond imagination. Glowing cities under transparent domes, artificial forests stabilizing the atmosphere, lakes filling ancient basins, and rivers flowing through a once-dead world. NASA, SpaceX, China, Europe, and private companies may unite to create the first human-made world, combining magnetic shields, orbital mirrors, and climate engineering factories. Piece by piece, step by step, Mars moves closer to becoming humanity's second home. Terraforming Mars isn't just science, it's a vision of our future. A future where humans don't just explore worlds, they build them. And if you enjoyed exploring this vision of our future, make sure to subscribe, because our journey into the universe is just getting started.